All right, let's settle this once and for all. What is the actual difference between mass and weight? Today, we are going to make it super clear. So you might want to grab your imaginary space helmet because we're packing our bags for a trip to the moon to figure this thing out. So picture this. You've packed your suitcase for this epic trip, and on the scale at home, it reads exactly 10 kilograms. You get to the spaceport, check it in, fly all the way to the moon, and you go to pick it up. The big question is, what happens to that suitcase? Does it still feel the same? To get to the bottom of that, we first need to understand what we've actually packed. Okay, first things first, let's talk about what's actually in your suitcase. You know, all the clothes, the gear, the snacks, all that stuff. Well, in physics, all of that stuff has a very specific name. It's called mass. Mass is, quite simply, the measure of how much matter, how many atoms and tiny particles are crammed into an object. It's the absolute, fundamental amount of stuff that makes up your suitcase and everything inside it. Now here's what's so cool about mass, and this is the really crucial part. It's intrinsic, meaning it's a core, unchangeable property of the object itself. It doesn't matter where you are, on Earth, on the moon, or floating out in deep space, the mass of your suitcase stays exactly the same. It is a constant, and we measure it in kilograms. So let's bring it back to our suitcase. The takeaway here is, your 10-kilogram suitcase on Earth? Yep, it is still a 10-kilogram suitcase when you land on the moon. The amount of stuff inside it hasn't changed one bit. But that's only half the story, isn't it? Because while the stuff in the suitcase is constant, there's this invisible force acting on it everywhere in the universe. And you know what I'm talking about. It's gravity. It's the reason we're all stuck to our chairs right now. Gravitation is this amazing universal pull. Seriously, anything that has mass, from a tiny grain of sand to a gigantic planet like Earth, is constantly pulling on every other thing that has mass. It's one of the fundamental rules of the cosmos. And here are the ground rules. Gravity always pulls. It never pushes. And the more massive something is, the harder it pulls, which is why we feel Earth's pull so strongly. And just like with a magnet, that force gets weaker the farther away you get. And this, right here, this brings us right back to our trip. Earth is huge, right? It's got a ton of mass, so its gravitational pull is super strong. The moon, on the other hand, is way smaller. It has much less mass. And because of that, its gravitational pull is only about 1/6 as strong as Earth's. That little detail, it changes everything. Okay, so let's recap. We have our constant stuff, which is the mass. And we have a pull, which is gravity, that changes depending on where we are. When you combine those two things, you get what we all feel every single day. Weight. See, weight isn't the stuff itself. Nope. It is the force that gravity exerts on that stuff. It's literally the measurement of how hard a planet is pulling on your suitcase's mass. And this is the big idea. Your mass is constant, but your weight? Oh, that can change a lot. And the relationship between them is actually beautifully simple. You just take an object's mass, which we know never, ever changes, and you multiply it by the local strength of gravity wherever you happen to be. The result? That's its weight. So, let's do the quick math for our suitcase back on Earth. We take its constant 10-kilogram mass and multiply it by the specific strength of Earth's gravity. And the result is a weight of 98 newtons. Now you might be thinking, wait, I use pounds or kilograms for weight? And you do, but scientifically, since weight is a force, its official unit is the newton. All right, touchdown. The rocket has landed, we've stepped out onto the lunar surface, and it is time to go to that baggage claim and see what's happened. How does our suitcase feel now? And here we go, the big reveal. Look at that. The mass, the amount of stuff, is exactly the same. 10 kilograms. No surprise there. But the weight? Whoa. On Earth, it was 98 newtons. But here on the moon, where gravity is so much weaker, its weight is a tiny 16 newtons. You could practically lift it with your pinky finger. I mean, the difference is just staggering when you see it side by side like this. It's the same object with the same amount of matter inside, but it feels incredibly light because the moon simply isn't pulling on it nearly as hard as the Earth does. And that's it. That is the entire secret right there. Same stuff, different pull. Mass is the stuff, and weight is the pull. The stuff stays the same, but the pull changes depending on where you are in the universe. Now, you might be thinking, okay, that's cool for astronauts, but why does this really matter to me? Well, this fundamental distinction is at the very heart of physics and engineering, not just in space, but right here on Earth too. It all comes down to this. Mass is the constant truth of an object. Weight
is its relationship with the gravity of whatever world it's on. Understanding that difference is absolutely key to everything, from launching satellites to just, understanding our physical world.
And to leave you with one final thought, astronauts up on the International Space Station are still really close to Earth. They experience about 90% of its gravity, and they obviously still have all their mass. So why do we call them weightless? What's really going on up there? You know what? That sounds like a great question for another explainer. Thanks for watching.